Hello everyone, I'm Jay Joshi and welcome to the 34th episode of Learning Java. Today we'll be learning about stacks. So, what are stacks? Now, this concept, you might have heard me use the word stacks in recursion. So, in recursion, I would have mentioned that when we do recursion backtracking, whatever we do backtracking is stored in the stack, which is nothing but the memory. So, what we are learning about is the concept of stack. We are not relating it to memory right now, we are just learning what stacks are and how we can implement them in Java. So, what is stack first of all? So, stack is essentially a linear data structure that is used for storing and organizing data in the computer's memory. Now, you all know what an array is, right? Let me give you an example of an array. So let's say I have an array over here. So you know how we draw this in a horizontal manner. So this is an array of length 5. 1, 2, 3, 4, 5. And these are the indexes 0, 1, 2, 3, and 4. And let's say this is an integer array. And we can store some values 4, 7, 10, 11, 12. Now, this array is used for storing data and you can organize data in this. So this is nothing but a data structure. And data structures are divided into two categories as you can see, static data structure and dynamic data structure. This array is a static data structure. And dynamic data structures are linked list and binary trees, which I'll be covering in a later video. So this is essentially what an array is, as you know already. Now, if I put this array, so you can see this horizontally, right? Now, if I put this array vertically, if I draw this vertically, the same array, nothing different, and this has 5 values. Again, this array of length 5. If I draw this vertically, this is called a stack. So stack is nothing but an array. So stacks can essentially be implemented through two ways, through an array and through a linked list. Again, a linked list we'll be covering in a later video. So right now we'll be only looking at implementation of stacks using arrays. So a vertical array is known as a stack. And stack we can use in our normal programs, although you won't find a use right now, you'll find it later on. Now, these are some of the differences between static data structures and dynamic data structures. You'll understand these differences better when we actually cover dynamic data structures. So if you want, you can pause the video and go through them right now. I won't be covering them at the moment. I'll be going through them later when I cover linked list and binary trees. So stacks can be, data structures can be divided based on operation into two categories, stacks and queues. Stacks we are covering today and queues I'll be covering in a later video. Queues are also very similar to stacks, but at the same time, they're very different. So, and again, both stacks and queues can be implemented through arrays or linked lists. So stack, as I already mentioned, it's a linear data structure and it's used for storing and organizing data just like an array. Now, what is this LIFO? LIFO is an acronym for a sentence, for a term I should say, last in, first out. So last in, first out. So stacks are technically last in, first out. So to explain this better, I want you to visualize something. Let's assume that you have a pile of books. So you always stack books vertically. So let's say you have a pile of 10 books. So one book at the bottom, another book above it, and then like that 10 books. Now, obviously the book you put at the last will be the 10th book. That's the book you put on the top. Now, for example, you want to access the 5th book in the pile. So to access the 5th book in the pile, you'll have to take out the top book first, then the second last and the third last, fourth last, and then you can access the 5th book. You can't just take out the 5th book because then the pile will topple over and you don't want that. So the book, you can see the book you added the last is the first one to get out. So this is what a stack is. So assume you have this thing. So, and this is a stack of, let's say, length 1, 2, 3, 4, 5. Now, the element you added the last, and these are the indexes, like a normal array, just you have to visualize it vertically. The element I add at the top, this is the topmost book, will be the element I remove the first. I can't remove this element first. I'll have to remove the top one. This is what last in, first out. So the element you added the last is the one you remove first. This is different in the case of queues, which I'll be covering later. Now let's have a look at what these stacks essentially do. So the major difference between a stack and an array, instead of this horizontal vertical thing, is in arrays you can access any element. For example, if I want to access this, I can just access the third index, first index, 0th index. I can access any element, anytime, anywhere. But in case of stacks, you can only access the topmost element. Just like a book, you can only use the topmost book. You can't take out the bottommost book, because to use the bottommost book, you'll have to take out all the books on top of that. So this is why in a stack, like a pile of books, you can only access the topmost element. If you want to access an element below that, you have to remove the topmost element so that the element below that becomes the topmost element. So this is why to access something, there's a top variable. So we have top over here. Now this top, when the stack is empty, points to the 0th index. Now currently you can see this top is pointing to the 0th index. And I can access only this 0th index now. So this is the terminology given to it. So for example, if I add an integer variable over here, let's say 4, then this top will add this where it's pointing initially, and then it'll increment and point to 1. So you can see over here, now this top is pointing towards the first variable. Why? Because we have added an element over here. If I want to add something 7 over here, then this top will point to this variable. If I add, let's say 10 over here, then it'll point to this. And then if I add something over here, then it'll point to the final thing. So this might look complicated, but trust me, it's not. So when you add the final element, just a second, the box got removed. So once you add the final element, the top pointer points to a space which is above the final index. So the value of top right now is 5, which is nothing but the length of the array, the length of the stack. So from this you can understand that if the value of the top is the same as the length of the stack, then the stack is full. If the value of top is 0, which means it points over here, this means the stack is empty. So this is an easy way to check if the stack is empty or full. And at the end, the top is pointing to nowhere. Okay. Now let's say you want to remove an element from the stack. How do you do that? Well, the easiest way to, the only and easiest way to do that is just to decrement the value of top. So currently the top is pointing towards the 5th index, which is nowhere because the stack is full. If I want to remove this element 15, I can't remove this element. To remove 10, I'll have to remove 15, 11, and then 10, like a pile of books. So if I want to remove this 15 element, all I have to do is decrement the value of top. So the value of top needs to become 4. So the top will point towards this. Now the 15 number will still stay at index 4. But as a programmer, we know that since the top is pointing towards the 4th index, all the indexes at 4 and above 4 will be empty, and all the indexes below 4 will be filled. We know that as a programmer, we don't need to put this value to 0 or something. If I want to remove the 11th element, I'll decrement the value of top again, and the top will point to the 3rd index. And as a programmer, I know that anything at 3rd index and above 3rd index will be empty. So we are just assuming these are empty. The numbers will still be there, but as a programmer, we know that these are empty. That's how we use a stack. And same case. So if I want to keep on deleting all elements, I'll have to keep on keep on decrementing the value of top. This is how you essentially do this. Now, for example, your stack is completely empty and the top variable is pointing towards its 0th index, and you try to remove an element. This will result in something called an underflow. And this is just a term. So if you try to decrement the value of top when it's already at 0, it'll result in an underflow. And if the stack is full, which means the value of the top is the same as that of the length of the stack, and you try to add an element, then it'll result in an overflow. So these are two terminologies you need to know. Now, these are the operations of a stack. So these are the operations: push, pop, pip, count, empty, full, and peek. So let's see what each of these operations are. So I already covered all of this. Now these are just the terminologies you need to know. So there's a stack of length 1, 2, 3, 4, 5, 6. The top is currently pointing towards here. It always points to the 0th index. If I want to add an element, I'll first add the element and then I'll increment the value of top. This action of adding an element is called push. So you push an element into the stack. So this is push. If I want to remove this element 7, I'll have to decrement the value of top. This is called pop. Removing an element from the stack is called pop. So you're essentially popping the element out. And again, if you try to pop out an element when the stack is empty, it results in underflow. And if you try to push an element when the stack is full, it results in overflow. Pip displays all the elements in the stack. So whatever elements there are, if there are no elements, it won't display anything. If there are like 3 elements, it'll display all 3 elements. This is what pip means. Count essentially counts the number of elements in the stack. And an easy way to count the number of elements in a stack is just to use the value of top. So whatever the value of top is, that is the number of elements in the stack. So you can see right now the top is pointing towards the first index, and there's an element over here. So there's one element in the thing. If the top points to the length of the thing, which is the index above zero, above the final index, then those are the number of elements. So this count essentially counts the number of elements in a stack. Empty checks if the stack is empty, so it's a boolean thing. Full checks if the stack is full, and peek is just used to look at the topmost element. You're not deleting that element, you're just referring to that element. So in this case, only 7 is the only variable. If I want to peek at this, I'll know that 7th is the topmost variable. That's it. This is what peek is. It won't remove the variable. So these are the essential differences between a stack and an array. Array is an inbuilt data structure, however stack is an abstract data structure. Arrays can be used to access any element, but stacks can only be used to access the topmost element. These are some of the operations of an array, and the operations of a stack are already covered. These are the operations of a stack. Now again, this is the same thing. The earliest received data will be at the bottom of the stack, and the most recently received data will be on the top of the stack. Now, how do you write the code for all these operations? So to implement a stack in Java, you use it as an array. You implement it using an array. So as a class member, you can declare an array of any name, and you can declare a top variable. And you can use that top variable to access any element and use it normally as an array. Just that you can access only based on the rules that the topmost element only you have to access. If you want to access an element at the bottom, you have to decrement the value of top. So this is a function push, and also if you want to use a stack, you have to use the same names given to all these operations: push, pop, pip, and others. If you just give it any creative name you want, like add or something, then it's not a stack, it's an array. So you have to give these specific names. So we are accepting the parameter int value val. This is the value we want to push. So first, always as a programmer, you have to check if the stack is full or not, because you don't want to push it when the stack is full, which is resulted in an overflow. So this is the overflow check condition. And if this condition is false, then you just put the value val in the top and then you increment the value. It's as simple as that. Similarly, pop to remove an element. In this case, it's int, you're returning an integer. So you're essentially returning the element you're popping out of the stack. So first, obviously, as a programmer, you check if the stack is empty or not, because you can't remove an element from an empty stack. That results in an overflow. So this is the condition you check for an empty stack. If it's not empty, then you just decrement the value of top and you're just returning the value which you have removed. So it's as simple as that. Now to practice more about stacks, I would recommend you write all the codes, all the functions for all these operations on your own and try to use the stack. Stacks right now won't be useful in your programs, because why would you use a stack? Why not just use an array? Because stack, you can only you have limited accessibility to all the elements. So it's better to use arrays right now, and I completely agree with you. There's no point in using stacks right now, but the stacks is actually useful in various other cases, which I'll be covering now. The applications of a stack. So first, I'll be looking at this application. It's used in backtracking. So as I mentioned in recursion, you go backtracking. So the stack is used in the same way. So for example, if you have a puzzle, a maze, and you're trying to find out the route for a maze, how do you like exit the maze? So you go one way. If that doesn't work, you go back, you go another way. This is where stacks comes useful, because it piles up elements and then you can go back in a sequential manner back to the first 0th index or wherever you want. So this is why it's used in backtracking. Then it's used to convert an infix expression to a prefix or postfix. What does this mean? Let's say I have an arithmetic expression a plus b. This is how we write our math. So this is a plus b. This is an infix expression. A postfix expression would be ab plus, where the operator comes after the operands. Prefix of this expression will be plus ab, where the operator comes before the operands. So stacks are used to do this conversion. Stacks are also used in parenthesis matching. So in the same case, let's say there are brackets in this expression, c plus brackets a plus b. It's used to match the left and right parenthesis in an expression. It's also used to evaluate a postfix or prefix arithmetic expression. So what this means is, in our computer, when we, let's say, type in our calculator 7 plus 13, which is 20, our computer doesn't just do 7 plus 20. It'll convert it to a postfix expression, postfix or prefix. So it'll convert it into 7, 13 plus, and then it'll evaluate the expression. So if we want to evaluate ourselves a prefix or postfix expressions, stacks are useful in that. And this backtracking already covered. And finally, stacks are used to keep track of the commands that were executed so that the latest action can be undone. So for example, you executed 5 statements. So first you executed something, then 4 more statements. If you want to undo some action, you can undo the last statement first, then the second last, third last, and so on, again in a sequential manner. So this is how stacks are useful. Again, just to learn more about stacks, you can do any of these operations you want. And right now they won't be useful, but later on you'll see how these stacks are useful. So that's it for today, everyone. Thanks for watching. And if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.